Hello, Precalculus class. Today we're going to look a little bit at the 6 trigonometric ratios. You've probably been introduced to 3, sine, cosine, and tangent. Probably the other 3 might be brand new. I'm hoping that you've already read some of the book in section 2-4, pages 73 to 75 at least, kind of explaining those a little bit so you have a little bit of background because I'm going to jump right in. Helpful to maybe read where the names tangent and secant come from. Try to understand that a little bit. Maybe read that 2 times. And yeah, we're kind of going to roll just with what are we defining these 6 trig ratios to be. So if u comma v is a point, r units from the origin on the terminal side of angle theta in standard position. So you have your kind of uv coordinate system, right? Sketch that into your notes. I do the u, the v, and we have an angle theta in standard position. It just means like somewhere out here, right? Possibly more than 90, more than 180. We have an angle like out here. That's theta in standard position, and then there's just some point that's on this terminal side here. Doesn't matter where you put it. Every point on that side will have kind of the same ratios. But if we put that point there and label it u comma v, draw the reference triangle that we were introduced to in the last class. Go straight back to the horizontal side here. Mark that as a right angle. Then this here, this displacement from 0, that's your u. This distance here is your vertical coordinate, that's your v. Both u and v will be negative in this case, right? Which is why we're talking about them as displacements and not distances. But r is just the radius. It's like how far from the origin to that point is it? That is a distance. It's always positive. We have our new definitions then of sine, cosine, and tangent. That the sine of theta is equal to v over r. The cosine of theta is equal to u over r. We haven't talked about the tangent yet, but you can probably infer if you know tangent as opposite over adjacent. Now we're just calling that the v over the u. Right. These names kind of come from that reference angle, right? If we draw in that reference angle here, it's just down there. There's theta ref. Right. Sine you know as opposite over hypotenuse. Opposite side of that reference angle is v. The hypotenuse would be that radius. Right, cosine adjacent over adjacent is kind of this u idea over r. We're just kind of getting out of the language of side lengths and into these coordinates because now we want to be able to make things be negative. There are 3 other trig ratios that are right tied to these that are the reciprocals of these that hopefully you read about in the book again, that are the cosecant of theta is the reciprocal of the sine ratio. It's 1 over the sine of theta. Another way to think about reciprocals is to just take this ratio and flip it. Right? Reciprocal would just be r over v. Reciprocal of the cosine is the secant ratio. Secant of theta is 1 over the cosine of theta. That's kind of the helpful way if you're trying to evaluate this with your calculator. Or you can think about it as r over u, the reciprocal of that fraction if you're making a fraction. Tangent is the reciprocal of that is the cotangent of theta. So 1 over the tangent of theta, or just u over v. So there's a few different ways that we will see this in examples. So I want you to, we're going to do 2, I think, today. 2 together in notes. There's a whole bunch more examples in the book. I'll kind of direct you where to go from those, but I want you to write this down with me here. Let's say the terminal side of angle theta just contains the point at -8, 3. So I want you to sketch angle theta. Standard position. And then find exact values. So no decimal approximations here. When we say exact, it should be like left as a fraction, square roots, everything in there, exact values for all 6 trig ratios. So that's it. That's enough information for you to be able to find like what are the rest of the trig ratios. All you know is that in a UV coordinate system, we have the point -8, 3 up here. -8, 3 would be your U and V coordinates, right? U would be -8, 3 is your vertical. That's going to be out somewhere in quadrant 2. So when you're sketching that, it's kind of helpful to think about that in advance, like where are you going, so you're not ending up with a whole bunch of dead space. So I'm going 1, 2, 3, 4, 5, 6, 7, 8 back in the U and 3 up in the V. I get this point out here that's -8, 3. Then I know that the terminal side of angle theta contains that point. So I'm going to sketch kind of just like that idea of a ray rotating from the origin. It goes through that point. And that's for any angle theta. It could be the one that was rotated just positively to get there, 150-ish degrees, I don't know, right? -200 and something degrees. It could be going around and around and around. It's not going to matter. It's going to have the same trig ratios every time. So we'll just sketch the easy one, call that angle theta. Right? And again, draw in that reference triangle. Right? That this V, is 3, and my U is -8 here. Okay. To find the trig ratios to this angle, I need to know U, V, and R. R is the only one I don't know, but this is just a right triangle. Right? The book just kind of assumes you're going to see exactly what to do here. You're going to use the Pythagorean theorem because you know like one opposite side here, you know one leg, you know another leg. Pythagorean theorem just says, right, it's a squared plus b squared equals c squared. In this case, we're going to just say u squared plus v squared equals r squared, and that will work every time. So we're going to use this to solve for r. So I'll write r squared equals, and plug in your u and v. U is -8, v is 3. So r squared equals, don't rely on your calculator to do this. What is 8 squared? When it's negative, a negative times a negative will become a positive. Positive 64. 3 squared is 9. So if r squared equals 73, which means that the radius is the square root of 73. This is an exact answer. Right? Like, don't change that value. Don't evaluate it. It's a 8.54 or something like that. Like, don't write that. Just leave it as the square root of 73. That is an exact value. So we'll put that in here. Go back to my black. And I encourage you, every time you do this, just rewrite those. So I have u is -8, v is 3, and r is the square root of 73. And you're just going to plug those all in to here to figure out what are my 6 trig ratios. Eventually, you'll have to memorize these. For now, you can come back to your notes and kind of look at these. Just try to be remembering in your head. Sine goes with the cosecant, cosine goes with the secant. But we have the sine of theta. That's v over r. Just plug it in. It's 3 over square root of 73, and don't touch it. That's your exact answer right there. The cosine of theta is equal to u over r will be negative 8 over the square root of 73. And the tangent of theta is v over u is equal to 3 over negative 8. I'm going to be a little bit picky about this. I don't like seeing negatives down here in the denominator. If I see that, just think, right, positive number divided by a negative number makes a negative number. Bring that negative sign just out front. Right? 3 over negative 8 makes negative 3/8. If you put it into your calculator, you'd get negative 0.375. Just pull that negative sign out front. I don't like to see negatives in the denominator. Okay. And all of these have kind of their corresponding, right, reciprocals. So to the sine, we have the cosecant of theta. Just flip that fraction. It's the square root of 73 over 3. It's r over v. Corresponding to the cosine is the secant of theta. It's going to be the flip of that. Square root of 73 over negative 8. Again, negative in the denominator. Just rewrite that. Right? The whole thing becomes negative. Put the negative sign out front of the whole fraction and write it like that. Sorry, without the negative there. Right. And reciprocal of the tangent. Tangent, the cotangent of theta is equal to negative 8 over 3. And you're done. Notice I never asked you what angle theta is. We could find it eventually. We're going to in the next section, section 2-5. But right now, like, all I'm asking is what are the ratios of the side lengths for this angle theta, whichever one it is. Is it that first 150 degree? Did it go around again to something past that? I'm just estimating it's 150 just because of the way I'm looking at it. Right? I don't actually know what the measure is. I think it's going to be a little bit more than 150 degrees. We'll do one more example here. Another way that you might see this. So one last quick example that you'll see in the book. Another way I like to ask these questions is find the 6 trig ratios for angle theta. Theta terminates in quadrant 4 and the cosine of theta is equal to 3/7. Right, so this is a new example here. So telling you the cosine of theta is equal to 3/7. Cosine of theta is u over r. Right? So I know that my u over r ratio is 3:7. Let's just pick 3 and 7 to be my u and be my r. Right? We'll say, let's let my u be equal to 3 and my radius be equal to 7. I just need to find now. Everything needs u, v, and r. I have u, I have r. I need to find v. Right? So to help us do that, let's sketch this angle theta. I'm telling you it's terminating in quadrant 4 here. So draw a sketch where I have quadrant 4. And I know that my u is 3. Right? Zoom in on this a little bit. And my radius is 7. It's hard to, like, you can't find 7 on the grid, but it's going to be somewhere, I don't know, down here a little ways away. Like, I'm not quite sure what it is. So just estimate, right? It has to go more than 6 units. But I can just label that my radius is 7 when my u value is 3. Again, out to that point, this is just, again, the thing continues forever. But this is just one point on it. I could also do like 6 and 14, and right, but the ratio and the smallest such one is 3 and 7 here. The only thing that I need to find then is my v. Right? What is my v equal to? Well, again, the Pythagorean theorem helps me figure this out. That u squared plus v squared equals r squared. I know u, I know r, so plug those in. I have 3 squared plus v squared equals 7 squared. So 9 plus v squared equals 49, which means v squared equals 40, which means v equals the square root of 40. Almost. Right? If I look at this, v equals the square root of 40. But what's wrong with that is the square root of 40 is a positive number. If you put that into your calculator, it's going to be positive 6 point something right up here. But I'm not in that quadrant. I'm down negative here. Right? If I was in quadrant 1, it would be 3, the square root of 40, and 7. But I'm down here in quadrant 4. As I know that it could be the plus or it could be the minus. Right? Like if you have like a squared equals 36, right? Like what number squared makes 36? Well, 6 squared makes 36. But also negative 6 squared makes 36. So if you're trying to go backwards, like I know that it has to be the plus or minus version of that square root. The square root of 36 is 6. But if I write it like this, maybe a is 36, or maybe it's negative, or sorry, maybe a is 6, maybe it's negative 6. I have to look at the quadrant to help me determine which it is. In this case, I know my v is going to be the negative square root of 40. So put that in up here. Is the negative square root of 40. I just know that right, in quadrant 4, v must be negative. Right? So that means therefore, so 3 dot symbol means therefore is the negative square root of 40. And then I can plug in, again, my u, my v, and my r into those trig ratios. So the sine of theta is v over r, negative square root of 40 over 7. Cosine of theta is u over r, 3/7. Better get that because that's what the problem stated at the very start. The tangent of theta, v over u, is negative root 40 over 3, and then their reciprocals. Cosecant equals 7 divided by the negative square root of 40. You can change that to bring that negative up to the top. Just negative 7 over root 40. Secant of theta is 7/3. The cotangent of theta is equal to 3 over negative root 40, which again is just equal to negative 3 over root 40. There you have it. There's a few example problems in the book that I'll have you do. Look up on the board for those, or I'll have them in the content library underneath this exact section of notes for you. So that's it. We'll see you next time.